Welcome back, everyone, to this episode of Dale's Rails. I got some good news this week. I got my transformer parts in, and I think I ordered these on Thursday. They came in on Monday. I was real surprised, and that gave me plenty of time. It didn't take long to get these repairs done to this transformer. It was really quick. I kind of spared you guys a video watching all that to include this other stuff. Kind of want to get this all condensed in one video. It's a lot of information I'm going to be going over here with you. This guy here, by the way, if you're needing your post-war parts, that's why I'm showing you this. He carries a full line of post-war transformer upgrades parts that you need. Your circuit breakers, your diodes, your carbon rollers. TVS surge. He sells. He sells quite a bit of stuff actually. Most of it's for like post-war models. He even sells the old bayonet and screw shell lights if you want to go that way to match your existing. He sells a good selection of all kinds of wiring. Especially, like the specialty flexible wiring that you use for your pickup rollers off your cars with pickups, so it's especially on your tenders, where you need that flexibility. And he sells them in full size reels or cut pieces. He cuts I think he has like little bags of them, probably 10-foot lengths, 20-foot lengths if you want that little. So he's very reasonable, and he's very thorough, and he's very quick to ship. So I haven't used him in a few years. It's been quite a long time ago that I bought all this stuff. Initially, I did refurbish my ZW, my KW over there, complete refurbishing that with diodes and circuit breakers and that type of thing. I never did do the circuit breakers on these. I think I just bought that one diode. I probably should have did the circuit breaker at that time, knowing what I know now. But back then, I wasn't as concerned about stuff like that as I am now. And that's why I wanted to cover this transformers with you a little bit, to give you a little bit about what's going on with the transformers and what your options are out there. And the main thing I want to point out first and foremost, though, is, I should have explained in my original video on this, where I was going in and ran into this problem with this diode. I went back and reversed these diodes back to the direction that the instructions showed you to install that. That is the correct way to install this diode, the way this transformer is configured. That's one of the issues with this transformer. It doesn't really give you any connections on the case here, how to wire this transformer, other than A and U and B and U. That's your selection. That's your variables. So that's the only two wiring selections it gives you on here. You'd probably have to have the original instructions. When you buy these now, they don't always sell these with it's very unlikely you're going to get the instructions. So you'd probably have to get the original instructions, or what I did take the time to, get some readings on here real quick for you. And here's these values up here. This is not the volts. This is V for variable. So all these values are voltage. So post A and U here is what's on the face cover. It's 5 to 16 volts variable. So that's A to U, that's 5 to 16, that's on there. And B and U is 0 to 11, so that's on the cover. But what's not on there are these three other values that it gives you. So post A and B is 5 volts fixed. B and C here is 11 volts fixed. And A and C is 16 volts fixed. Well, without having the original instruction sheets, you wouldn't know that. And the other problem I have with my particular installation, why I ran into this on my layout in the first place, is that my layout is, I took the time to draw this little diagram up to give you guys an idea what I'm talking about here. My layout is what they call a common ground bus wired layout. It's old school, how you would do a conventional style layout if you got multiple block sections that you want interconnected between each other to make everything run. To do that, you have to phase your transformers. And that's where the problem was. This transformer, for it to be wired and phased off of this primary with my other transformers, I had to reverse the polarity on A and C here, or A and U there. I'm sorry, on A and U I had to reverse that. And that's why I wrote down here at the bottom of this little transformer schematic I made. I put on here, when phasing 1033 with ZW, KW, and the CW transformer, meaning they're all phased together, you have to reverse post A and U to the track if you're using C for fixed voltage. And when I first did my layout, the outer loops were done, and that inner city loop was the last thing I did. And it was kind of one of those things, as as we do as building the model railroad, you kind of start here and then you progress to here, and then things change along the way. Well, that's kind of what went along with this transformer. Initially, I laid that track in there. I was running everything off of the variable voltage. With this transformer phased with my other transformers, everything was fine. And I could travel between block sections unimpeded with no problems until I decided that I had a strict 20-mile-an-hour speed limit in my inner city loop, and that variable voltage setting was just not going to be enough power to throw my switches. So that's when I decided to wire into the fixed voltage of this transformer. When I did, it threw everything out of phase between this transformer and my other transformers. So I found that out when I couldn't drive a train in there without it shutting my whole system down. It's one of those things that you're not expecting that to happen, so you're not really sure what happens, and that's what it was. And so then I tried to reverse that by just unplugging the plug and changing it around, because you can reverse polarity on these transformers two-way, either on the primary side here by plugging in your non-polarized your plug up here to your receptacle, just rotating it. And that didn't work. So what I ultimately had to do was flip-flop A and C here. And when I did, everything worked fine. That's just what I did to get it to work. Well, that transformer's been like that ever since. And I obviously have not ran an engine in there with solid-state sound systems in it until that day when I did this one. Otherwise, I would have discovered this a long time ago. I have ran some engines in there. Most of the diesel engines I ran in there did not have sounds in them. And, I have ran some post-war whistle tenders in there. So that's why it wasn't an issue, because this diode will sound the whistle on a post-war tender, no matter which way your polarity's done on this transformer. That's not the case with the solid state. So that's what I ran into. And since I planned to change these transformers out anyway, before this even happened, my needs are growing here to my outer loop. I need to upgrade that to a more powerful transformer, just because my growing power needs there. So when I do, I'll move one of those CW80s over there to replace this, and that's my ultimate goal anyway, long term. When I initially did that, I want all my lower loops interconnected through solid state transformers. So that's where I'm going to probably run most of my solid state style locomotives and engines equipped with sound systems and stuff like that. My upper loops on my post-war transformers, that's a good place for me to run those. That's a higher capacity transformer, more capable running the power demands of those Pullmore style AC open frame motors up on that loop. So it's just the way I arrange my track plan. It just gives me the capability to do all that. That kind of what goes into when you're designing your layout. That's part of the design when you're doing it. Just that because you're going to if you're going to try to mix old with new, that's one of the issues you're going to run into. And here's the little circuit breakers. You can see they even got the double-sided tape on it for you, and we got the little spade terminals. And these are specifically designed for the 1033 with a 5 amp setting. So these are only rated 5 amp, and your 90 watt transformer, that's plenty large for that 90 watt transformer. If you do the math on that, that's exactly 5 amp. But you know, we're going to get into it later. I'm going to go over this a little more in depth. I think it's a good time to talk about these transformers, especially you know, the post-war versus your modern solid state, and you know, the pros and cons. And so this is kind of nice. I got these little spade crimp-on spade terminals, and so that's going to make it easy for the install. Well, this transformer, between the three of them, I didn't have one I could really use because the one that was in good shape, the cord wasn't. So, you know, that's out. So I got a replacement cord. You know, I'm replacing it, and do that one on this real quick. And you know, these cords a lot of times are, you know, one's going to have like some kind of identification mark on it, like a rib. You know, this cord, the plug on the end of these, they're not polarized, so it doesn't matter which wire goes where necessarily. But what I'm going to do is I'm going to find the identified one on this one, and I'm going to put the identified wire, which is going to be this left side here. So I'm going to match that up. This cord will go back in there like that. It's kind of just laying for me like I need it anyway. It's just, you know, it's just asking like it needs to go back in like that. So these two cords with the identifying mark, I don't know if you guys realize that these cords, a lot of times, one has some type of identification, either have a stripe or ribs, something that distinguish one wire from the other. In this case, this just has actually one little rib, one little vein. It doesn't even have, you know, a lot of times they'll have like several ribs in it, but this just has one rib to identify it. And this replacement is, you know, it's got a couple of them. Yeah, this just has one. So I'm just going to go ahead and replace this the same way. And, you know, I've already tried this transformer, the trick of unplugging over here at the wall. You know, if you want to change polarity on these, a lot of times, these transformers, except for this one, it doesn't work that way. Easiest way to change polarity is unplug and plug it back in. And I've tried that several times here to be sure, because I was kind of surprised. This transformer is just a different kind of a transformer. So okay, that's good. Okay, so there's that cord in. Tie a little knot in it here. Knot's important. It's kind of your strain relief, so you got to tie a knot in your cord. And about right there should do it. Yep. So there's that. Screws out. What's holding up on it here? like how that's a problem, but I'm gonna get that out of the way. Okay, so it's just going over those. There we go. There it is. All right, so there that is. The two connections they give you, I wanted to show this to you guys. We're going to turn on our meter here, and this meter here is a it's actually an amp probe multi-tester, so it actually will do volts and amps. So right now, when you first turn it on, it always defaults to AC volts, and you can see by that wavy line there on these meters, you know, whether it's here at your volts or the wavy line on your amps, the wavy line on your, that means AC current. So this orange dash with the dotted lines, that means DC. So this meter, you have to look down here, it's going to tell you if it's on AC or DC volts. So you have to physically switch between the two. But when you first turn this meter on from the off position, it always defaults to AC volts. Just FYI, you're going to have to check your meters. And then you have your selector buttons down here to change it back and forth between those two types of systems. And I wanted to show you something here you could run into when you're testing this on top of this. So this transformer, you know, when I turn it on, you know, it's on now. I shouldn't, by rights, get any measurements on my variable voltage, right? We're going to check U and A, which we know that's variable. But if you look at that meter over there, it's giving me 5.2 volts. And I had an engine setting on there, and nothing's lighting up or working. So why am I reading a voltage? Well, these digital meters are very high impedance. That's why you see it ranging now. It's probably reading the inductance of the electrical current in my body. That's how sensitive these are. So to stop this, to get false voltage readings, the easy way to stop that is just put a load of some kind. You have to make sure you know it's on. You know, with these engines, you know, the motors may not be engaged, but the lights usually are. So an engine's safe bet. You could probably use a caboose. This engine, I know, always defaults to the on position. So I'm going to have the load of not only the lights, but the motors, CAN motors themselves. Now when I test this, I probably should read 0. So if your meter's not reading 0 when you're testing out there at your track or at your transformer, and you don't have an engine or something sitting on there or something drawing a load like lights, even a whistle tender, you may read some voltages. So you can get false voltage readings. This can make you look like you don't know what you're doing. Trust me, because that's the problem with these digital meters. They're that sensitive, so they will read the most sensitive electronics there is. It's probably overkill for an electrician. This is probably great for somebody in electronics, but you can see it's measuring something now, and I don't even have these leads touched anything. So that's just because of high impedance of these meters. They're going to do that. But the problem of it is, that isn't such a big deal. But what you don't want to see when if you don't have an engine sitting on there, you don't want to look like you have 5 volts to the track. So to do that, put a load on there, any kind of load. Now if I go to the next one, that's AU. The next was AB. That should be 0 to 11. And I'm reading almost 5 volts there. Why is that? I got a train sitting on there. Well, I don't have this terminal hooked up to the lock-on, do I? So it's reading no load. Now, if I move this wire over there with the engine setting on there, I'm moving it to this setting. Trust me, that meter will zero out, just like it did over here. Now you can't do this on the fixed, of course, because the fixed voltage, as we're going to see here, according to my new little measurements here, A and B is 5 volts. So here's A and B. So with this transformer just sitting there, and it doesn't have anything to do with variable voltage, so you can't shut it off with variable voltage. I'm reading 5 or close to 5 volts, 4.9 volts. I'm going to call that 5. And so that terminal's live as long as this transformer is plugged in. There's no way to shut that off. So now I'm going to go to post B and C, and I should read 11 volts. Okay, there's 10.95. That's pretty dang close to 11, I'd say. And then if I go back from C, what was it, to A, I should get 16. 15.85. So that's telling you these posts are always hot as long as this transformer's on. That's why you want to be very careful of getting any metal objects up here around these posts, especially if these transformers are on. Not so much it's not like you're going to get electrocuted on it. I mean, most people are really, especially old guys like me, we're so dried up, we have no resistance. So we probably can't, I don't even know if we could fill 90 volts. Most people won't fill any kind of voltage until you get up to 90. So it's not like this is really unsafe from electrocution hazard or shock hazard. It's more of a fire hazard, actually. So, because if stuff's up against these terminals, fortunately I put a new fast-acting circuit breaker in there. But with that old circuit breaker that was in here, that could be a problem, because if it's not tripping, these terminals will just sit there until it overheats. I don't know how many of you have ever ran across a derailed train car with plastic trucks and see your trucks melted. Well, that's what causes that. It's because the transformer's not de-energized itself from the circuit because the circuit breaker's faulty. So I wanted to point that out, those items, and I think when we got this meter out, we can take and I can show you here real quick in case you're wondering about that too, I guess. I take the test leads out. I'm going to throw a load on this. Hopefully that engine. So I'm going to crank that all the way up. I just have the lights of that locomotive. And so we're going to get back here a little bit. So I've taken the test leads out, and now I'm going to adjust this over to amperage. So now I'm on AC amps. So to test the amp draw of what those light bulbs are drawing, it's not checking the load of the motors, because that locomotive be flying off the table if I check that. And just so you know, these ratings, to get your amp draw, you have to go to the maximum rating. So you'd almost have that engine, on a elevated up off the track so it can't run, and then crank it up and get those motors running. Then you could get a good amp draw that way, I suppose. It just wouldn't have much load on it. So the load of that, I clamp that around a single conductor. That's what you do. It doesn't matter which one. You just don't want it, this clamp, you can't have it around both at the same time. You've got to just have it around one conductor or the other. So I'm on the other conductor. You can see that's 0.26 amps. And then if I go over to the other conductor, see, it doesn't matter. Hey, it does. It's 0.28 amps. It's a little bit more under that one. Maybe I got a bad connection. Yeah, I do. So that's under that one. Didn't change anything. So it is a little bit different, but it's going to get pretty close. We're just off a couple of thousandths. So that's how you check the amps. It's just that easy. It's a digital clamp-on amp meter. So you have to actually have that clamp and close completely get your fingers off of it. You don't want to leave it open, and have it closed completely. And that's just how you check your amperage on your conductors. Like I said, it's got to be around the same conductor. So if you have a 2-wire running from here, not separated out like that, you'll have to separate them enough to get it to round 1. I don't know what's going to happen if I can do it round 2. Blow something up. Oh, I made that train run. Oh, you make that train run when you do that. We learned that. I don't ever do that because I do what I'm supposed to, so it's fun to figure out what happens, I guess. When you do something you're not supposed to do, you know, we just know what we're supposed to do. We don't know what we're not supposed to do. We're not trained to figure out what we're not supposed to do. So that was kind of interesting. I wasn't expecting that. Boy, and I had that cranked up. So there you go. We had a little bit of fun, entertainment there, I guess. Well, I thought I'd show real quick what happens if you clamp this meter around both wires. A while ago, apparently I bumped a wire. That's all it was. And that's why the engine took off on me. No, I didn't find a new Lionel operating control system. But, you know, in case it turns out to be a thing, you saw it here first on Dale's Rails. So we're going to clamp this around there. I hope this thing doesn't take off again. Yeah, see, it just goes to 0. I'll bet you guys thought that engine was going to shoot off there again, didn't you? But speaking of bizarre things, I'm going to have to break this video up after all because I had another peculiar thing happen again while I was down here, and it's gonna take some explaining to do because it's something bizarre. I was running this locomotive. You know, this is starting to be a habit. I'm starting to get a little bit concerned about this. Every time I shoot a video, something else goes wrong, and it gets more bizarre every time. And just to give you a little bit what I was dealing with here, I put my 736 on there to, you know, run in a video, and it was running fine, and something happened. It derailed or quit running and derailed. I can't remember. And so I think I fixed the derail and then turned the transformer back on, and it had a post-war whistle tender on it, and the whistle tender came on immediately and would not shut off. And no matter what I did, I couldn't get the whistle tender to shut off, short of just killing power to the track. And I could never figure it out what was wrong. Now, I recently cleaned the contacts on that transformer because I had my stuff out working on the other transformer on that, and thought maybe I did something in that process because it didn't do that when I first ran the train. And then so I brought this over here because this engine quit running after that. And it turns out, you know, the E-unit drum apparently sheared the post off. And while I had this apart, you know, you can see there's only one out of those 4 fingers that are still good. I don't even know how that E-unit was working. Those other fingers are burnt off. So I'm going to have to replace the fingers in here. I mean, these bottom fingers are good. They should look like those. And you can see how those look. They are definitely what we call gunny sack. So I'm going to have to repair this. And then I finally got the whistle tender problem figured out with the transformer there. And I still don't really know what caused it. And I still don't really know what fixed it. And I'll have to go into more detail on the next video with you. And I've got some more information I'm going to be doing on the transformer, especially for you that are interested in maybe trying to figure out what's a good transformer option to select for your layout. And I'm just going to kind of give you some differences between mainly the post-war style versus solid state. So until next time, you've been watching Dale's Rail. Be sure to tune in for the second edition of this episode. Thanks for watching.